All right. Next section we're going to cover is section 9.2. This really is just a continuation of 9.1. It's going to look very familiar to what we've already done. We've already learned all the buttons on the calculator that we need to push. Now we're just going to put it all together. Okay. So after verifying, that's what we did in section 1, we verified that a linear correlation between the two variables is significant. Remember, that was the R value. After we determine that, the next step is to determine the equation of the line that best fits the model. And again, we talked about this just briefly, but we didn't go into a whole lot of detail in section 1. Now we're really going to talk about it. The line that we discovered last time is called the regression line. Sometimes the line of best fit. And the biggest thing that's so important is that this equation can now be used to predict the value of y for a given value of x. So this now becomes a predictor. And in stats, that's kind of what we're trying to do, is predict the outcome of something. Predict something based on some stats. So this will allow us to take these variables, make a connection, and more importantly, make a prediction. So consider the scatter plot below. For each data point d, I represents the distance between the observed value and the predicted y value. So basically, we're looking at, this is the observed value, this is where we predicted, and this is the distance between. And that distance, that difference between those two, is called a residual. And it can be positive, it can be negative, and it can be zero. Distance may not be the best word here. It might do better if we actually put difference. The difference between the two. It is a distance, but we'll talk about difference. Okay. And again, a line of best fit is the line in which the sum of the squares of the residuals is at a minimum. So we're trying to decrease the difference between these values. So we're trying to make these distances smaller and smaller. Right. In algebra, we learned that we can write the equation of a line by finding the slope, which is m, and the y-intercept, which is b. From that equation, we have y equals, this didn't print real well, so y equals mx plus b, where m is the slope, how steep the line is, b is the y-intercept, which is where it hits the y-axis. So if we look at this line right here, where it hits the y-axis, this is your y-intercept right here. That's how it was written in algebra. In stats, we use a new figure or variable, and we actually read this as y hat. It looks like there's a little hat on top of it. So we're going to use y hat instead of y. And on your calculator, and we did this at the end of section 9.1, we had y equals ax plus b, where a is the slope and b is the y-intercept. So basically, everything is similar to the way you learned it in algebra. The difference is just in the variables. So this is very similar to algebra, with some of the variables different. Particularly the slope one. A versus M for slope. And then the y hat versus y. So don't let the new terminology bother you. It's exactly what we've learned before. It's no big deal. And basically, it's going to be even better because we get to use our calculator to help us find this. So again, using your technology to find the line of best fit or the regression line. So calculator steps, again, basically we already did this. Basically, we already did this. Okay. But just as a refresher, we're going to hit Stat, Enter, and we're going to hit the data, X values into L1, Y values into L2. Then we're going to, this is step 1. Step 2, we're going to hit Stat, and instead of Enter, we're going to do Calculate, go over to number 4, which is the linear regression, AX plus B. So Stat Enter, and then Stat Calc. And number 4 is your linear regression. It's a little bit different in the book. In my opinion, they should teach both of these sections together. They don't. They split it up. And the main reason is they want to make sure there's a correlation before we try to find the line of best fit. But when we do this calculate second or number 4 linear regression, this gives us both the line of best fit and the R value, the correlation coefficient. So technology puts them together. Your book separates them out. To try to find this by hand is not easy. I'm not even going to show it to you because it is much more difficult than grabbing a calculator. However, you have to practice your calculator. You have to know how to do the entering of the data and then finding the line of best fit. So if we did this, and again, we're going to get the answers off our calculator. So if we go back to our calculator, all right, we hit Stat, Edit, Enter to edit and enter the data. Then we're going to hit Stat, Calculate, so over 1. And then number 4, I'm going to tab down to number 4, hit Enter. And by default, all of this is already done for you. So you can just leave it the way it is because it's default. If you hit Enter, then you end up with exactly what we had at the end of section 9.1. And here are your results. The A value, the B value, the R2 value, and then the R value. So once you do the linear equation, we get the y equals ax plus b. Tells us that the A value is 199.5346. The B value was 56.0357. The R squared value was 0.7632. And the R value was the 0.8736. This is your line of best fit. This first three. So we're going to take y equals ax plus b and put it together. So y equals 199.535x plus 56.036. Remembering that this is the slope. This is your y-intercept. And for our stats, we're just going to change the y equals to y hat. So y hat equals 199.535x plus 56.036. This is a line. It's in the form of y equals mx plus b. So just like in your algebra class, that is your line of best fit. If it doesn't ask you to graph any of this, you don't have to graph it. Most of the time we don't graph it. Most of the time we don't go back and put it on our calculator and see the picture of the line. You can certainly if you want to see the picture of the line. We did that last time as well when we entered it into y equals 199.5x plus 56.03. And then when I hit graph, I got the scatter plot and the line, remembering that we are using the same data set throughout all of the examples in section 9.1 and 9.2. If you don't want to see the line, and in section 9.2, it doesn't even talk much about putting it with the scatter plot, so you don't have to ever see the line. You don't ever have to use to find the graph. However, basically what we want to do then is predict y values based on my equation. So again, this is going to be y hat equals 199.535x plus 56.036. This didn't print very well. Not sure what's going on with that. So it says now use this equation to predict the expected carbon dioxide emissions from the following gross domestic products. So use this equation to predict. Remember, the carbon was the y value for the following gross domestic products, which was an x value. So this is an x value. $1.2 trillion is an x value. We want to find y. We do this with straight substitution. So y hat equals 199.535. This is an x value, so I'm going to put 1.2 plus 56.036. Using my calculator, I'm going to put 199.535 parentheses 1.2 plus 56.036, hit enter, and I get 295.478. So again, let your calculator even do the substitution for you. So we end up with y hat equaling 295.478 million metric tons of CO2 emitted. That's what makes this line of best fit so important, because now I can make predictions. I can actually find out what might happen in the future. So in the future, if we spend $2 trillion on the GDP, the gross domestic products, how does that affect the O2 emissions? Well, we're going to have y hat equals 199.535 times 2 plus 56.036. Again, if I use my calculator very carefully, and you can verify this, you should get 450, there's a 5 right here, 455.106 million metric tons of CO2. What if the GDP were 2.6 trillion? Then we would have y hat equals 199.535 times 2.6 plus 56.036. And my y hat, my predictor, would be 455. No, wait, sorry about that. My predictor then, my y hat, I would predict to have 574.827 million metric tons of CO2. So y hat's your predictor. Based on a number, what's the prediction? All right. So now, putting everything that we learned in section 9.1 and 9.2, I want you to do this problem. So you complete this. All right. Look at your data set. It's a lot larger data set this time. It's a lot larger data set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We now have 26 pieces of data. So be careful when you put this into your calculator. Remember that x's are going to go in L1. Here's more x's that are going to go in L1. Your y's are going to go into L2. Right? So you should have 26 L1s and 26 L2s. Be careful and make sure you enter the data correctly. If you don't enter it wrong, your calculator is only as smart as you are. So if you're entering the data wrong, you're going to get bad data out. I want you to draw the scatter plot. Make sure that you adjust that window. That window is the most important thing. Then find the line of best fit, your p hat. Show what your calculator gets for a result. What is that correlation coefficient? What is that R value? And what does that mean? Is it a good correlation, a bad correlation, a positive, a negative, a strong, a weak? What is it? Add your line of best fit to your scatter plot above. So I do want you to go back to number 1 and actually put that line of best fit in there. And then 5 says to use the line of best fit to predict the time until the next eruption given the duration. So again, the duration is your x value. So this is an x value. And we want to find y. Once that's completed, you can turn in all of your notes. And that is going to wrap up section 9.1. I mean 9.2.